This is AQA A-level Chemistry. It is a required practical question from paper 3, and this one is based on RPA4. Going to recommend, as always, that you pause on the question, have a go, and then review your answer once you've tried it for yourself. This is the entirety of the answer on screen here, or the entirety of the question. When you're ready, let's take a look at the answer. So we have got a question about sodium halides. State what is observed when silver nitrate solution is added to sodium fluoride solution. Now, actually, a lot of the time that is spent teaching about this and learning about this is related to silver chloride being a white precipitate, silver bromide being cream, silver iodide being yellow. But it is important that you also remember silver fluoride is soluble. It doesn't form a precipitate at all. So we end up with a colourless solution. Part B, state one observation when solid sodium chloride reacts with concentrated sulfuric acid. So, in this case, the observation that we make is white fumes, but it might be easier to do the equation first. You've got to remember that all of the sodium halides with conc sulfuric start with exactly the same reaction, and that is where essentially the Na displaces one of the H's in the sulfuric acid. So we get NaCl and H2SO4 going to NaHSO4 and HCl. So what is the Cl- acting as? Well, that then takes us into the acids and bases topic. It was Cl-, it's now HCl. That means it's accepted a proton, which means it's acting as a base. Let's move on to part C. Give an equation for the redox reaction between solid sodium bromide and concentrated sulfuric acid. Explain using oxidation states why this is a redox reaction. Now, some people will advocate learning these equations. I absolutely do not. I would say learn the rules of redox, apply them, and you've got very limited facts you need to learn. We know that bromide, when it is acting as a reducing agent, will be oxidized to bromine, and we need to know sulfuric acid can only reduce it as far as SO2. So what I now need to do is build those half equations, so 2Br-, and from there I'm going to need 2E- on the right hand side, showing us that it's oxidation. On the next one, H2SO4 and SO2, my S's are already balanced, so I'm going to add 2H2O to balance the oxygens. To balance the hydrogens, I add 2H+ on the left, and to balance the charge, I'm adding 2E- on the left. I now need to combine them. I can see that I've got 2E- on the right on the first one, 2E- on the left on the second one, so I don't need to do any multiplication up. So I can simply combine those together and I get the equation that you can see here. H2SO4 and 2HBr go on to make Br2, SO2 and 2H2O. Now from there we need an explanation that this is redox, and it does say really carefully using oxidation states. So we are going to look at more than one species, because I can see that the bromine oxidation state has gone from -1 to 0. It's been oxidized, but that doesn't tell us it's redox. We also need to say that sulfur has gone from +6 to +4, and that is reduction. It's only when we can prove reduction and oxidation that we can show that this is redox. Finally, on part D, state what's observed when aqueous chlorine is added to sodium bromide. So this is about the oxidizing ability of the halogens. It's a practical that I'm sure you will remember when you think back to it. It's one that you did at GCSE as well. And what we're going to see here is that there will be a yellow-orange solution of bromine made, because chlorine is a powerful enough oxidizing agent that it can displace the bromide from sodium bromide. And the equation that goes with that, where we can see it, is Cl2 reacts with 2Br- to make Br2 and 2Cl-. That takes us to the end of this question. Thank you for listening, and goodbye.